Okay, as you can see, the title says Keq and Stress Example. And this represents the toughest type of math of equilibrium question I will throw at you. Reading the question is really important. You're going to be a bit like a detective. It's giving you lots of critical information. The first sentence gives us equilibrium concentrations of 3 chemicals. And if we have those concentrations, that means we can come up with a Keq value. And that's very important because we're going to need that later on. The second sentence is all about a stress. It says we add some iodine to an equilibrium system, so we're going to throw it out of equilibrium. And ultimately, we're going to calculate the concentration of all the chemicals at the end based on our ice chart. So it reminds you, it says write out all pertinent information. So information that the question's trying to give you. As usual, we want to write a Keq expression, and the big thing is knowing whether or not to write out ice chart. In this case, we're going to need an ice chart. And we're going to have to solve for x. So we start off nice and simply. So we go boom, and boom, and boom. And we say, here's our Keq expression, and we're going to substitute those numbers in. And you probably did not need a calculator when you look at those numbers. And you find it equals 400. Now, we had these original equilibrium values. The hydrogen did not change. The HI did not change, but the iodine did change because we added the 0.005, and so it becomes 0.0015. So we're going to write these 3 numbers down again. Normally you wouldn't. This is just for emphasis. Well, the I2's gone up, so the equilibrium has to go to the right. So this is going to be a minus x, this is going to be a minus x, and this is going to be a plus 2x. It's gone to the right, making more product. Coefficient matters. Remember, in this level C, that's where the coefficients come into play. Now, sadly, we don't know what x equals, so a bit of algebra is ahead of us. But we now have these equilibrium values that we can plug into our Keq expression. So here we have our Keq expression again. And we plugged in our numbers, and we know that has to equal 400. Unfortunately, we don't get a perfect square on both sides. So we have to expand things out. So this denominator hops the other side. Now we're going to FOIL and multiply by 400. So you can see lots of steps means lots of chance to mess up. And once we've done that, we're going to gather our like terms. And if you're lucky and have a nice graphing calculator, you can find your zeros. If you're unlucky like me, you're going to have to use the quadratic equation. So we have an A of 396, a B of minus 10.80, and a C of 0.020 that we're going to plug into our quadratic equation. So when we do this, we arrive at this in the terrible square root symbol there. And notice the minus 10.80 and minus became plus. And we get 2 possible values of x, 0.0020 or 0.025. And typically one of them we can throw away. And we would just put an x right through the 0.025 because it's too big. It's bigger than the value of the stress, so that makes no sense. So we have to use this one. Don't know if you can see me circling it, but try to circle it right here. Oh, there we are. Circle that. And then we can go back and plug this value in for each of these. So there's the H2. We now know the value of x, so we get 0.0080. Here we get 0.013. And here we get 0.204. Now if you put down the 0.20, we're keeping those because it's going to make it a little tidier at the end. If you got rid of that 0, we can live with that for sig figs. But the nice thing here, it says we can check the answers. We can plug these back into our Keq expression right here. And so we put those numbers we calculated in, and it happens to equal 400. And that gives us total confidence that we did this question properly. Lots of steps, lots of chance to make a mistake. And that's why it's important to check your answer and write things out clearly, spread out your work so it's easy to troubleshoot if something goes wrong.